Measures of center and spread. This is an extremely important video. There's a lot of times in just in the media when people talk about things that pertain to money. And hopefully by the end of this video, you'll see that most distributions that deal with money, you should refer to the median as the most stable measure of center instead of the mean. And you'll be surprised how many times this is violated. So this is kind of what, again, just kind of keep in mind as we go through this. When we deal with something pertaining to money, why is the median the best measure of center and the quartile is the best measure of spread to describe those? So by the end of this video, that should be, yeah, I don't know, hopefully be clear, okay? So the purpose of this assignment is to examine the mean and median in the presence of outliers. So a few facts. If our histogram is bell-shaped and symmetric, then the mean and the median are approximately equal. We'll see that in this illustration coming up. If our histogram is positively skewed or right skewed, then the mean will be larger than the median. If our histogram is negatively skewed or less skewed, the mean will be less than the median. And the standard deviation is the preferred measure of center. I'm sorry, the standard deviation is the preferred measure of spread when the mean is the preferred measure of center. And quartiles, and IQR, is the preferred measure of spread when using the median as a measure of center. So guys, summarizing that, just to give you something to go into your notes, we have two measures of center, the mean and the median. And in practice, we report both of these. But when we need to rely on one of these when they're drastically different to tell the best picture, or I'm sorry, to paint the best picture, to tell the most appropriate measure of central tendency, well, which one of these do we choose? And again, that's the purpose of the video. But what I want you to know right now is when you choose this one, then the standard deviation is the measure of spread that you will depend on for variability. If you choose the median, the quartiles, Q1, Q3, and the difference between Q3 and Q1 will be the measure of spread that you will depend on. So guys, it all depends on which one of these you choose. Choose the mean, report the standard deviation. Choose the median, report the quartiles as the preferred measure of spread. Okay? Now, how do we know which one to choose? Well, that's one of the goals of this video. All right, step number one, let's begin with the following data, and we have 9 scores. And what I want you to do is enter these into your calculator, okay? Shape of the distribution, let's find the mean, find the median, or other outliers, and how do the mean and the median compare. So, guys, this should be pretty easy to do now because we're hopefully getting better at our calculators. So I'm just going to use L1. So I'm going to clear it out first. So I go clear, enter. So I'm going to type 10, 11, 11, 12, 12, 12, 13, 13, 14. Go back to the last one. You can see that right there that I have 9 numbers, and that's exactly what I need. So just check for typos and make sure that it's all good. All right. Now, shape of distribution, we're going to want to do a histogram. So guys, remember, we go to histograms, we go to stat plot. So second stat plot, I would make sure all these are turned off, because if you get, for example, if you have this one on and this one on, and sometimes those things can give you corresponding outputs that will cause an error. So the easiest way to just get all these off to begin with is come down here and hit the number 4 and hit enter. Now you shouldn't have any, when you go back to it, you shouldn't have any reason to get an error. Now if you do get an error, sometimes you have to go to y equal and make sure that you don't have anything in here. Scroll all the way down, make sure that you don't have anything in there that's messing stuff up. So stat plot, first thing we need to do is turn it on. Let's choose a histogram. And I put my data in L1. So I need to scroll back up and hit zoom 9. And guys, that's about as bell-shaped and symmetric as you will ever get. All right, some people will call that a normal distribution. It's not right. A normal distribution is a theoretical distribution that represents a population. We have scores. This is bell-shaped and symmetric. Next thing is, what is the value of the mean and the median? Well, guys, we can do that very quickly now. Go to Stat, go over to Calc, one variable stats, and I want L1. So I can see my mean is 12. And I can scroll on down, and I can see that my median is 12. So just as we said right back up here, in a bell-shaped and symmetric distribution, the mean and the median are going to be awful close in value. And in this case, because it is so perfectly bell-shaped and symmetric, our mean and our median are the same. Now, are there outliers? I don't know. We need to check. To check for outliers, we need to construct a box plot. So we got it turned on. The box plot that I want you to choose is this one right here. Guys, you got to select Enter to get that. And scroll back up. So see L1, frequency 1. There's the mark that if we have any outliers, whatever you choose here, that's what the outliers will look like. So I'm going to scroll back up, go zoom 9, and I can see that I get no outliers. So finally, how do the mean and the median compare? They are equal. All right. Step number 2. We will now add a new score. So now you're going to have the same numbers that we had before, but you can see we're going to come in and add a 25 to the numbers that we had before. So guys, let's do that. Let's go to Edit, and I'm going to scroll all the way down to the bottom of the first list, and I'm going to add a 25. So you can see now that we have 10 scores instead of 9. Crazy. 9 plus 1 is 10. All right. So by adding this one score, and you can kind of eyeball it, although you never would, but you can kind of eyeball it and see that that 25 falls outside the realm of the other 9 scores. So it's very, very, very likely this thing is an outlier. So let's see how adding an outlier to a perfectly bell-shaped and symmetric distribution, how that affects things. So first of all, let's go with the shape of the distribution. So second function, stat plot. And let's choose the histogram button. All right, everything's good down here. I got to scroll back up so we don't get an error, and go zoom 9. Well, guys, that's a positively skewed distribution. And that's exactly what positively skewed distributions do. They screw up good bell-shaped and symmetric distributions because of an outlier. That 25 alone was so out of the typical range of our scores that it completely changed the distribution because it's an outlier. So outliers create these skewed distributions. So what is the value of the mean and the median? Well, guys, we can do that just like we did before. We can see that the mean now is 13.3. And we can scroll on down, we can see that the median is 12. Now, if I remember correctly, the median was 12 before, but the mean was also 12. So that outlier only affected the mean. The median was stable in the presence of outliers. So, well, first of all, we don't even know 25 is an outlier. So let's go ahead and technically classify it as one. So we do a box plot. All right, scroll back up, zoom 9. And you can see if we go up here and hit trace, that we can hit the right arrow and scroll over and get the 5-number summary. That 14 is the biggest number in our data set that's not yet an outlier. Once there's separation, then this is an outlier. So because this is separated from the main frame of the box plot, this is an outlier. So 25 is an outlier. There's one outlier and its value is 25. So what can you conclude from this? Well, by adding a large value, the mean chased the outliers, but the mean was stable in the presence of outliers. All right, step number 3. Which value, the mean or the median, was least affected by the outlier? Well, clearly the median. How did the mean and the median compare in value? Well, guys, the mean jumped up above the median. If you were to make a statement about a typical score on this quiz, would you feel more comfortable reporting the mean or the median? Would you feel more comfortable reporting a measure that was significantly affected by one score? Or would you want to take the measure that was stable in the presence of that one score? Guys, I want the stable measure. I'd report the median. So guys, when we have when we have a data set that is in the presence of outliers, the median will almost always be the most stable measure of center. All right, step number 4. Let's revisit the original data set, but now let's add a score of 0. So you should now have the following 10 scores. Be sure to replace the score of 25. All right, so I'm going to go into here. And your calculator is kind of clever. You don't have to put things in order. So I can just change that 25 to a 0. So now what happened now? Before I added a 25, which was 11 numbers higher than the highest. Here I'm adding a 0, which is 10 numbers lower than the lowest. So I'm kind of doing just the opposite. Instead of adding a big number to the right, I'm adding a big number to the left, so I'm adding a much smaller number. But nevertheless, I can go up here and do stat plot. And I can come down and select box plot. I'm sorry, select the histogram to get shape of the distribution. And I can go zoom 9. So guys, what happened here? Well, we get something that has a negatively skewed value. So the distribution is negatively skewed. What's the value of the mean? Well, the mean moved to 10.8 and the median remained at 12. Are there any outliers? Yes. If I hit trace, you can see that the value we added as 0 is an outlier for the same reason I described before. So there's one outlier and its value is 0. So this thing is a 0. So guys, what happened? When I added a smaller number, the mean chased it. The mean was at 12. It chased the lower number. When I added a bigger number, 25, it chased it. So guys, in the presence of outliers or outlier, the mean is not a stable measure of center because it will chase the outliers. The median is a stable measure of center because it doesn't chase the outliers. Step number 5. Which value, the mean or the median, was least affected by the addition of the outlier? Clearly the median. How did the mean and the median compare in value? Well, in this situation, our mean was less than the median. So in a negatively skewed distribution, your mean is going to be less than the median. In a positively skewed distribution, as we saw in step 3, the mean is going to be bigger than the median because our outliers are smaller in negatively skewed distribution and our outliers are bigger in positively skewed distributions. If you were to make a statement about the typical score on this quiz, would you feel more comfortable reporting the mean or the median? Do you want one that was highly impressed with one score, or do you want the stable measure? Guys, I always go with the stable measure. So guys, step number 6, I believe this is the last question. Yeah. Examine what you've learned by answering these questions. In the presence of outliers, which create skewed distributions, is the mean or the median the most stable measure of center? Clearly the median. It doesn't chase the outliers. It's the most stable measure of center. What measure of spread do you think should be reported in the presence of outliers? Well, we said early on that if we choose the median, then the measure of spread that should go with the median that corresponds is the quartiles. Now, you might be thinking, well, why is that? All right, well, think about it. If we arrange our data from low to high, and we want to find the median, what do? Well, we come in and we find the center score. We then usually come in and look at the numbers below it, and we come in and find the median of that. Look at the scores above it, and we find the median of that. What have we found? Q1, Q3, the median. The natural measure of spread around the median are the quartiles. All right? What if we come in and find the mean? What measure of spread is built around the mean? Standard deviation. Remember that ugly thing we did many moons ago? We took each score, saw how far it was from the mean, squared it, divided by n-1, took the square root, for reasons I explained in a previous video. So the standard deviation is the measure of spread that is built around the mean as its center. So guys, when we report the mean, we're going to report the standard deviation as the appropriate measure of spread to express variability. So bullet 3, the mean and the median are approximately equal in a bell-shaped and symmetric distribution. Which do you think should be reported? Well, you report the mean because it's just better understood than the median for most people. Every single student that walks in my class knows what the average is. Add up your scores, divide by how many you get. The median, although it's not much more complicated, it's not as well understood as the mean. What measure of spread should be reported? Obviously the standard deviation. Now, guys, I started out this video talking about money. You can almost rest assured that any distribution that pertains to money will be positively skewed. Why? Well, let's just look at annual income. If we go from $0 to $100,000, that bar is going to be the highest because it's that range of family incomes that you'll find a lot of people in our country. From 100,000 to 200,000, there are a lot of families that make between 100,000 and 200,000, not near as much as between 0 and 100,000, but still quite a few families. From 200,000 to 300,000, less families. From 300,000 to 400,000, even less. From 400 to 500. Once we get out here way to, way out here where I can't even relate to, like a million, there's not many families out there, so the bar's not going to be very high, is it? There's not many families that make, $1 million family income. And I mean, we can go out here a long way. I mean, Warren Buffett and Donald Trump and, Bill Gates. I mean, I went out there a long way. I mean, I could go all the way over to my wall over here. There are people, but there are not many of them, so these bars are not going to be very high. But nevertheless, that's going to cause a skewed distribution. And guys, if you don't remember anything else in this video, distributions that deal with money are almost always going to be positively skewed. So the most appropriate measure of center to depend on will be the median. And the most appropriate measure of spread will be the quartiles. So if you're moving into a large city, let's say, for example, you get a job offer in San Diego, a large city, and you're wondering, can I even afford to take this job? How much is housing going to cost? So you contact some sort of housing authority in San Diego, and they tell you that the mean value is given, and then they tell you the median house price. So they tell you the mean house price, and they tell you the median house price. Concentrate on this one, because this mean house price was significantly affected by these people making tens, hundreds of millions, even billions of dollars, probably tens to hundreds of millions. And I don't know about you, but if I'm going to move to San Diego, I got to keep it real and look at something typical. I can't look at a value that's artificially inflated by a lot of rich people. Well, not a lot of rich people, actually very few rich people compared to the masses of people. So guys, again, the median is the most appropriate measure of center in almost all situations when you're dealing with money. All right, guys, important stuff there. That's the end. Take care.